That first blast of ice-cold water hit my skin at exactly 6:16 a.m. on a Monday morning, and I swear, time momentarily stopped. My lungs seized, my muscles contracted, and my brain erupted in what can only be described as the biological equivalent of a system-wide panic alarm. Every instinct in my body was screaming at me to escape, to turn the handle towards that comforting red mark that promised warmth and comfort. Instead, I forced myself to remain under the frigid stream, my hand gripping the shower wall as if I might be washed away by the intensity of my own physiological response. This was day 1 of my 7-day cold shower challenge, an experiment I had approached with a mixture of curiosity and apprehension after encountering repeated claims about the potential benefits of cold exposure. From Silicon Valley executives to professional athletes, wellness influencers to longevity researchers, it seemed everyone was suddenly advocating for the transformative power of voluntary cold stress. The purported benefits ranged from increased energy and improved mood to enhanced immune function and accelerated recovery from exercise. Some advocates even claimed that regular cold exposure could optimize hormone levels, boost metabolism, and strengthen resilience to both physical and psychological stressors. As someone with a natural skepticism toward health trends, I typically approach such widespread claims with caution. But the cold shower discussion had moved beyond the realm of wellness influencers and into peer-reviewed research papers, with findings from institutions like the Huberman Lab at Stanford University, the Wim Hof Research Consortium, and the Department of Human Biology at Maastricht University, suggesting there might be legitimate physiological mechanisms behind the anecdotal benefits. Still, I had questions. Would a mere 7 days be sufficient to experience any measurable changes? What was the minimum effective dose of cold exposure needed to trigger adaptive responses? And perhaps most importantly for someone who genuinely despised being cold, was the discomfort truly worth whatever benefits might emerge? To create some structure around this experiment, I established specific parameters. Each morning for 7 consecutive days, I would conclude my normal warm shower with a minimum of 60 seconds in the coldest water my shower could produce. I would gradually extend this duration throughout the week if tolerable, aiming for 3 minutes by day 7. To create accountability and gather data beyond my subjective experience, I committed to tracking several metrics: morning heart rate variability, HRV, using a chest strap monitor, subjective energy, and mood ratings on a 1 to 10 scale recorded 30 minutes after showering, sleep metrics via my tracking ring, and brief journal entries documenting my immediate psychological response to each cold exposure. Before diving into what happened, it's worth understanding the science of why acute cold exposure affects the body so dramatically. When cold water contacts your skin, temperature receptors immediately activate, triggering what physiologists call the cold shock response. This involves several simultaneous reactions. Peripheral blood vessels constrict, vasoconstriction, shunting blood from your extremities to your core to preserve heat around vital organs. Your sympathetic nervous system, the fight or flight branch, activates rapidly. Stress hormones, including norepinephrine, flood your bloodstream, and your breathing pattern changes dramatically as respiratory muscles contract. This cascade of physiological responses explains why that first morning felt so intensely uncomfortable. My body interpreted the sudden cold as a legitimate threat to survival and mobilized accordingly. What makes cold exposure interesting from a physiological perspective isn't this initial shock response, but what happens when the body is repeatedly exposed to controlled cold stress, a process researchers call hormetic adaptation, or where a moderate stressor actually triggers beneficial adaptive responses. Day 1 of the challenge was, without exaggeration, an exercise in mindful suffering. The initial 60 seconds under cold water felt like at least 3 minutes, with my mind desperately searching for distractions from the intensity of the sensation. My breathing became rapid and shallow, precisely the opposite of what cold exposure experts recommend, and I found myself involuntarily gasping. The moment my timer indicated I could exit the shower, I practically lunged for my towel, my skin covered in goosebumps, my muscles tense and shivering. What surprised me, however, was what happened approximately 3 minutes after I'd dried off and begun dressing. A distinct wave of alertness washed over me, different from my usual coffee-induced morning wakefulness. This wasn't the jittery, slightly anxious energy that caffeine sometimes produces, but a clear, focused alertness, accompanied by what I can only describe as a subtle mood elevation. The subjective experience aligned with what researchers at the Psychiatric University Hospital Zurich have documented regarding cold exposure's effects on catecholamine release, particularly norepinephrine, which affects both attention and mood regulation systems. By mid-morning of that first day, I noticed another unexpected effect. I felt unusually productive and resistant to distraction. Tasks that typically required significant willpower to initiate seemed to require less motivational struggle. This observation aligns with research from the Department of Human Physiology at the University of Oregon, which has documented how acute cold exposure activates certain prefrontal cortical regions associated with attention regulation and cognitive control. Day 2 brought marginally less dread as I approached the shower, though the initial shock remained intense. The primary difference was that I managed to implement controlled breathing, deliberately slowing my respiratory rate and taking deeper breaths, despite my body's instinct to gasp and hyperventilate. This breathing control noticeably reduced the subjective discomfort, a finding supported by research from the Department of Physiology at Wayne State University on how respiratory regulation can modulate the autonomic nervous system's response to cold stress. By day 3, I extended the cold exposure to 90 seconds and noticed that the initial shock, while still significant, dissipated more quickly. Where the discomfort had remained relatively constant throughout the exposure on days 1 and 2, I now experienced a noticeable adaptation around the 45-second mark, as if my body recognized the stimulus and adjusted accordingly. This timeline aligns with research from the University of Copenhagen on how rapidly the human vascular system can adapt to repeated cold exposure. The mood and energy benefits I'd noticed on day 1 became more pronounced and consistent. My morning heart rate variability measurements, an indicator of autonomic nervous system balance and stress resilience, showed a modest but consistent increase from my baseline measurements. More subjectively, I found myself experiencing fewer mid-afternoon energy dips, and even noticed I was less reactive to minor stressors throughout the workday. I want to speak directly to you watching this video right now. Have you noticed how many of our modern comfort-seeking behaviors actually undermine our resilience? How the perfectly temperature-controlled environments, the endless digital distractions, the immediate gratification of food delivery apps, while convenient, may actually be weakening our capacity to handle discomfort and stress? This cold shower experiment forced me to confront how thoroughly I had organized my life around comfort-seeking and avoidance of even minor physical discomforts, potentially at the cost of the very resilience I needed to navigate life's inevitable challenges. If you're finding value in understanding these effects of voluntary hormetic stress, consider subscribing to this channel. Unlike typical wellness content focused on comfort maximization or aesthetic transformation, we explore evidence-based approaches to building genuine physical and psychological resilience. The comment section below is open for your experiences. Have you noticed changes in your energy, focus, or stress response when deliberately embracing certain forms of hormetic stress? Your observations might help others connect these important dots in their own health journey. As I reached the midpoint of my experiment, day 4 brought a significant shift in how I related to the cold shower. The physiological shock remained. Certain biological responses to sudden cold exposure don't fully habituate, which explains why cold water immersion maintains its effectiveness as a hormetic stressor, even for experienced practitioners. However, my psychological relationship to the experience had fundamentally changed. Rather than approaching the cold with dread and resistance, I found myself curious about the sensations, even slightly anticipating the clear-headed alertness that I now consistently experienced afterward. This psychological shift reflects what researchers in behavioral psychology call expectation recalibration. The brain updates its prediction models based on repeated experiences, particularly when the anticipated negative consequences, in this case, unbearable discomfort, prove less severe than expected, and unexpected positive outcomes, enhanced mood and energy, emerge. Studies from the Department of Cognitive Science at University College London have documented how rapidly such expectation updating can occur when consistent pattern violations are experienced. By day 5, I extended the cold exposure to 2 minutes and noticed a new dimension to the post-shower experience, a sustained feeling of accomplishment that lingered well into the morning. Intriguingly, the sense of achievement appeared disproportionate to the actual challenge. Objectively speaking, standing under cold water for 2 minutes isn't particularly impressive compared to many other physical feats. Yet subjectively, the act of voluntarily embracing physical discomfort first thing in the morning created what psychologists call a keystone achievement, a small victory that positively influences subsequent behaviors and perceptions throughout the day. Research from the Johnson Laboratory at Columbia University helps explain this effect. They've documented how successfully completing a challenging task early in the day increases both self-efficacy, your belief in your ability to accomplish tasks, and alters the brain's reward processing for subsequent tasks. Essentially, that brief cold shower was creating a neurochemical win that recalibrated my threshold for what felt challenging or uncomfortable throughout the rest of the day. The physical adaptations became more noticeable as well. My initial shivering response had significantly diminished by day 5, and the vasoconstrictive response, that intense painful sensation as blood vessels near the skin surface constrict, became less pronounced. These adaptations align with research from the Environmental Physiology Laboratory at the University of Portsmouth, which has documented how repeated cold exposure modifies both the shivering threshold and the vascular response, essentially teaching the body to maintain functionality under cold stress more efficiently. My sleep tracking data revealed another unexpected pattern. While this overall duration of my sleep remained consistent with my baseline, the deep sleep percentage had increased by an average of 11% since beginning the cold shower regimen. This observation is consistent with findings from the Sleep Research Laboratory at the University of Chicago, which has documented how controlled exposure to specific physical stressors, including cold, can increase slow-wave sleep, the most physically restorative sleep phase, likely through modulation of core body temperature rhythms and certain inflammatory signaling pathways. By day 6, I found myself implementing what cold exposure researchers call anticipatory breath control, deliberately slowing and deepening my breathing before the cold water even hit my skin. This pre-exposure regulation noticeably reduced the intensity of the initial shock response. Physiologically, this represents a learned regulatory adaptation where the higher brain centers, prefrontal cortical regions, impose control over lower brainstem responses, effectively saying, "We've experienced this before, and it's not a threat requiring maximum response." This particular adaptation may be among the most valuable transferable skills from cold exposure. Research from the Department of Integrative Physiology at the University of Colorado has demonstrated how the ability to maintain regulated breathing during acute physical stress correlates with improved autonomic regulation in other high-stress contexts. Essentially, cold exposure may be training a form of physiological stress resilience that generalizes beyond the specific challenge of cold. Day 7 arrived, and I extended the cold exposure to the full 3 minutes I had initially targeted. Rather than the celebratory mindset I had anticipated for the final day, I made it. I found myself fully present with the experience, implementing the breathing techniques that had emerged throughout the week, and observing with curiosity how my body responded. The shivering was minimal, my breathing remained controlled, and while the cold was certainly still uncomfortable, it no longer triggered the panic-adjacent response of those first exposures. The post-shower measurements on the final day showed the most pronounced changes. My heart rate variability had increased 17% from baseline. My subjective energy rating was 910 compared to my typical 6-10 pre-experiment, and my mood assessment similarly reflected significant improvement. These subjective reports aligned with objective measurements tracked throughout the week, specifically higher heart rate variability, improved deep sleep percentages, and subtle but measurable improvements in fasting glucose levels each morning, an average decrease of 4 milliliters DL, suggesting improved glucose regulation. Beyond these measurable metrics, I noticed broader patterns emerging in my behavior and mindset. Tasks that would typically trigger procrastination seemed to present less psychological resistance. My willingness to engage with other forms of beneficial discomfort, like maintaining focus during challenging work projects rather than seeking distraction, appeared subtly enhanced. Even my response to minor frustrations, a delayed shipment, a technology malfunction, city traffic, seemed less reactive and more measured. These observations align with research from the Department of Psychology at Tilburg University, which has examined how regular hormetic stressors can create what they term cross-tolerance to other forms of stress. The proposed mechanism involves both psychological factors, increased self-efficacy and stress mindset changes, and physiological adaptations, improved hypothalamic pituitary adrenal axis regulation and autonomic nervous system balance. As the experiment concluded, the question naturally arose, would I continue the practice? The evidence, both from my direct experience and the supporting research, suggested that cold exposure offered legitimate benefits with minimal downsides. Yet I was equally conscious of how easy it would be to drift back toward comfort-seeking behaviors without the structure of a formal experiment and the accountability of documenting my experience. The decision to continue emerged not from willpower or discipline, but from a more fundamental shift. The cost-benefit calculation had changed. Where previously I had perceived only the discomfort of cold exposure, I now had direct, embodied experience of the subsequent benefits. The momentary discomfort now appeared as an investment rather than a punishment, a perspective transition that researchers in behavioral economics call temporal recalibration, where the perceived distance between an action and its reward shortens through repeated experience. I did make several adjustments to create a sustainable long-term practice. Rather than committing to daily cold showers indefinitely, I adopted a schedule of 5 mornings per week, allowing flexibility while maintaining sufficient frequency for continued adaptation. I also adjusted the duration based on available time and energy levels, using a minimum of 60 seconds as my baseline while extending to 3+ minutes when circumstances allowed. This implementation of minimum effective dose thinking is supported by research from the Huberman Laboratory at Stanford University, which suggests that even brief cold exposure, when practiced consistently, can maintain many of the adaptive benefits while significantly reducing the psychological barrier to adherence. Dr. Huberman's research indicates that consistency matters more than duration once the minimum threshold for triggering adaptive responses has been reached. Another key insight emerged regarding the timing of cold exposure. Throughout my experiment, I had placed the cold session at the end of my normal shower routine. Research from the Department of Human Biology at Maastricht University suggests that transitioning from warm to cold maximizes the norepinephrine response, precisely the neurochemical associated with the mood and cognitive benefits I experienced. This contrasts with approaches that advocate for cold-only exposure, which may offer different benefits but potentially reduces adherence for beginners due to the substantially higher discomfort level. Looking beyond my personal experience, it's worth acknowledging that cold exposure represents just one form of hormetic stress, defined as a beneficial adaptive response, triggered by moderate exposure to stressors that would be harmful in larger doses. Other forms include certain exercise patterns, intermittent fasting protocols, heat exposure, sauna, and even specific breathing practices that temporarily alter blood chemistry. What unites these approaches is the fundamental principle that appropriate doses of stress, rather than being harmful, actually trigger adaptive responses that increase resilience. This principle runs counter to much of our modern wellness messaging, which often frames stress uniformly as something to be eliminated rather than selectively engaged as a growth stimulus. Research from the Department of Health Psychology at Harvard University has documented how this stress mindset, whether we view stress as uniformly harmful versus potentially enhancing, significantly impacts how our bodies respond to stressors, literally changing gene expression patterns related to stress adaptation. The cold shower experiment ultimately provided more than just the specific benefits of cold exposure. It offered a tangible experience of how voluntary engagement with controlled discomfort can build capacity and resilience that extends far beyond the specific stressor. In a culture that increasingly optimizes for comfort and convenience, often at the expense of the very challenges that stimulate growth, deliberately embracing hormetic stress may represent a crucial counterbalance.